Okay. Next is about the some interesting patterns of a square numbers. This is really interesting. See what happens. Pattern number 1. The sum of two consecutive triangular numbers is a square numbers. What is actually these triangular numbers? The numbers whose dot patterns can be arranged as a triangle. For example, if I say 1 and 3, see, this is the triangle. This is also small triangle. 6, this is also a triangle. 10, okay, this is also a triangle. Like this we can arrange whose dot patterns, this is important, whose dot patterns can be arranged as a triangle. Therefore, this is called triangular numbers. Any formula is there to obtain these triangular numbers? Yes, of course. That is given by n into n plus 1 upon 2. If you put n is equal to 1, you can get 1 plus 1, that is 2, you can get 1. If you get 2, 1 plus 2 plus 1, that is by 2. This is 2 here, 2, you can get 3, like that you can get numbers. How can I, for example, first you can, if you write 3 here, 1 I will write simply by dot, 3, 2 dot here and 1. If you write 6, next 6, you can continue add more dot, that is 1, 2, 3 and 2 here, like this. Again next 10, 1, 2, 3, 4, 1, 2, like this. Sorry, you can write 1. Yes, here and here. See, the dots decreasing a dot. 4 is there, 3 is there, 2 is there, 1 is there. 3 is there, 2 is there, 1 is there, like this. 5 is there, 4, 3, 2, 1. Like this it is decreasing, the dot patterns are decreasing. You can easily write. First, if you write base, that is how to write. If I directly write the 15 as a triangular, 15 whose as a triangular number, in a triangular number. If I say like that, where I should say 5 here. I can't. What is the base? Dots are 5. How can I conclude it? No, I can't write like that. But before going to write this one, I have to see the previous one, from starting from 1 to 10. 1 to 10. Then you can easily write 15. The next number, if you want to write next consecutive number in a dot form, in a triangular form, you should know this previous one. Okay, these are the things. Well and good. Now, my question is not that one. What the sum of two consecutive triangular number is a square number. See, sum of consecutive triangular numbers. This 1 plus 3 I will take. I will take 1 plus 3 is a square number, is it? Okay. 4 is a square number? Yes, of course. Next, if you take 15 and 21, of course 15 plus 21 is equal to 36. Is it a square number? Yes, this is square number. This is the interesting property. uh, I'm telling that it is interesting. We see here this can be arranged in a dot form. Even we can conclude this one by dot patterns also. For example, 1 plus 3 is a square number. See, we add it. If you add this 1 plus 3 in the dot form, this becomes square. Of course, see here, this is, if you dot one more, this is the 3, is it? Plus 1 I will dot. This is implies that I will add the dot, this dot here. What is becomes? It becomes square. See, this is how we can conclude even from dot also. This is that's why I am telling this is very interesting. The sum of two consecutive triangular number is a square number. Can you understand what I am telling? Even you can compare these 3 and 6 with in the form of dot. Okay, see here how. For example, 6 is there. How can I write 6? 1, 2, 3. Okay. Now to make this is 6 plus 3. What is actually 3 here? 3. You can easily write you can add here one more thing. How many dots added here? 1, 2, 3, 4, 5, 6. These are previous dots. Previous dots added are 3 here. 1, 2, 3. What is that? Becomes again square. You can conclude from the next interesting property is there are 2n non-perfect square numbers between two consecutive square numbers. Consecutive square number, I will tell you. 1 square, 2 square, 3 square, 4 square. These are the, you can easily write square. Now, if I take 2 square and 3 square, okay, 2 square and 3 square, that is equal to n is equal to what here? N is equal to 2 here. N is equal to 2 here. Okay. N is equal to 2 here. Now 2 square and 3 square, that is 4 and 9. Okay, 4 and this 4 and 9, these are two consecutive square numbers. 2 square and 3 square, that is multiplication 4 and 9. These are two consecutive square numbers. Definitely we agree. Between these two consecutive square numbers, there exists 2n. That is 2 into n is equal to what? 2. That is 4. 4 non-perfect square numbers. Is it correct? 5, of course it is non-perfect square number. 6, of course it is non-perfect square number. 7 is also non-perfect square number. 8 is also non-perfect square number. You can easily conclude with an example. Yes, of course. Definitely there are 2n non-perfect square numbers between two consecutive square numbers. We can easily conclude with an example.